Today we will find the expression for the fringe width of Young's double slit experiment. Okay, so what is the arrangement? We have a we have two slits which are separated by a distance small d, and there is a screen which is at a distance capital D from the slit line, and we are considering a point P which is at a distance from the central point of the screen O. The central point means the point on the screen at which the path difference of all the rays coming from S1 and S2 is 0. That is, we will get a bright fringe there. So let the rays be S2P and S1P. So to find out the expression for the fringe width, what we need to do, we need to find out the path difference first. So let's say we are taking S2P square minus S1P square. So if we apply the formula for A square minus B square, what we will get? We will get S2P plus S1P multiplied by S2P minus S1P. Now the left hand side term that we have, it can be written in terms of xn small d and capital D from the diagram, that S2P square is equal to xn plus d by 2 whole square, and S1P square is equal to, sorry, whole square, and the base is there. If we consider the triangle, as you can see, capital D, so xn plus d by 2 whole square plus capital D square minus xn minus d by 2 whole square minus capital D square. So this should be the term in the left hand side, and in the right hand side we will make the approximation that xn, sorry, the S2P and S1P both are almost equal to the separation between the slit line and the screen, that is D. So the first term S2P plus S1P, that will give us 2 capital D, and the second term that we have, that will actually give us the path difference S2P minus S1P, and let that path difference be delta L. So we are writing the values of all these quantities, and by simplifying we are finding out the path difference delta L, and the path difference delta L is, as you can see, will come as xn small d by capital D, xn small d by capital D. So this should be equal to the integral multiple of the wavelength of light to have actually the constructive interference at P. So this path difference should be equal to n lambda, where lambda is the wavelength of light and n is the order of the bright fringe. So if we actually put the values, then we will find out xn as n lambda capital D by small d. So this should be actually the position of the nth bright fringe from the central point O on the screen. Similarly, to have the n plus 1th bright fringe on the screen, we must have xn plus 1 as n plus 1 lambda capital D by small d, because we just need to put n plus 1 in place of n. Now if we actually subtract xn from xn plus 1, that is if we actually subtract the position of the nth bright fringe on the screen from the position of the n plus 1th bright fringe on the screen, we will actually get the fringe width. So if we just put the values, we will see fringe width, which is denoted by beta. It will come as xn plus 1 minus xn. It will only come as lambda capital D by small d. So this will be the value of the fringe width or expression for the fringe width in case of Young's double slit experiment. I hope you have understood. Thank you.